We are continuing our study of polygons, looking specifically at quadrilaterals. And we'll be working in lesson 6.1 in your textbook today on page 393. We have our fillable notes that you will follow along as we go through the lesson. We're going to begin with the diagonal definition of a polygon. What is the diagonal of a polygon? In any polygon, I have a specific number of vertices. In this case, I have a six-sided polygon with 6 vertices. A diagonal is a line segment that connects any two non-consecutive vertices from one vertice. So if I call this vertice A, B, C, D, E, and F, I can connect diagonals from A to any vertice that is not right next to or not consecutive. Consecutive vertices would be vertices that are right next to each other. So in this case, a six-sided polygon has three diagonals from any vertice. Notice that it breaks it up into 1, 2, 3, 4 triangles. So when I draw diagonals from a vertice, if I have the number of sides 6, my number of triangles that are created by my diagonals is n minus 2, or in this case, 4. If I could use some words to define it, I would say that a diagonal is a segment connecting any two non-consecutive vertices. This leads us to an interesting conclusion about the interior angles of a polygon. If you remember from our recent study of triangles, if I add up all of the angles of a triangle, A, B, and C, I will actually get 180 degrees. So I could do this by tearing off my angles and placing them in an orientation where I could see that I now have all three angles would add to be 180 degrees. So in the case of my six-sided polygon, I've created 1, 2, 3, 4 triangles. That would be 180 degrees plus 180 degrees plus 180 degrees plus 180 degrees, which would give me a total of 720 degrees in a six-sided polygon. Now remember, we said that the number of sides minus 2 will give me the number of triangles. So I can come up with a interior angle sum theorem that says I can find the total of the interior angles of any polygon if I take the number of sides, I subtract 2, and multiply by 180 degrees. In a long form, that would be the measure of angle A plus measure of angle B plus measure of angle C plus D plus E plus F is equal to the number of sides minus 2 times 180 degrees. In this case, we had 720. So let's use this theorem and look at an example. Our first example says to find the sum of the measures. That's the sum of the measures, adding up all the measures of the interior angles. Those are the angles inside my polygon of a convex heptagon. The first question we have to ask is how many sides are in an heptagon? Well, I've looked it up for us using dictionary.com. You could also use your textbook. A heptagon is a polygon having 7 angles and 7 sides. 7 angles and 7 sides. So I have a heptagon. 1, 2, 3, 4, 5, 6, 7 sides. Using the interior sum theorem, I know that the number of sides minus 2 times 180 degrees will give me the total if I add up all 7 of my angles. That's going to be 7 minus 2 times 180 degrees, which is 5 times 180 degrees, which is 900 total degrees. So I have 5 times 180 degrees is equal to 900 degrees. If I add up all 7 of my interior angles, it will equal 900 degrees. Now, how could I check this? One way I could check my answer is to choose one of my vertices and draw all the possible diagonals. This gives me 1, 2, 3, 4, 5 triangles. I know that if I have 5 triangles, each triangle adds up to be at 180 degrees of its interior angles, which also gives me 900 degrees. Both ways are acceptable. They're directly related. One is a theorem that looks like a formula, n minus 2 times 180. The other uses diagonals to come up with the same formula. Let's look at another example. Find the measure of each interior angle of a quadrilateral ABCD. So now I'm asked to find each of the measures given some information. One of the first things I need to decide is, what do these things add up to total? Well, I know that I have a quadrilateral that has 4 sides. So if I add up all of my angles, I will have 4 minus 2 times 180. That gives me 2 times 180 degrees for a total of 360 degrees. If I add up angle A, angle B, angle C, and angle D, the measure angle A plus the measure angle B plus the measure angle C plus the measure of angle D, I will get 360 degrees. Now, I've been given some good information. I know that angle B is 90. I know that angle C is 90. They've told me with my right angle mark. So I know that angle B is 90 degrees, angle C is 90 degrees. I also know that angle D is x degrees, and I know that angle A is 3 times x degrees. All of those are equal to 360 when I add them up. Now I can combine like terms. 90 plus 90 is 180 degrees. 3x plus x is 4x. So I've reduced my left side of my equation. That is all equal to 360 degrees. I can subtract 180. That leaves me with 4x is equal to 180 degrees. I'm running out of room, but I will divide both sides by 4, and that will leave me with a solution of x is equal to 45 degrees. Now, am I done? I'm not quite done yet because it asked me to find the measure of each interior angle. I have not answered the full question yet. Remember to answer the full question. I know 2 of my angles, 90, 90. I know that x is 45, which means angle D is 45 degrees. And angle A is going to be 3 times 45 degrees, which is 135 degrees. Now I have answered the question, the measure of each interior angle. I'm going to clean this up a little bit so we can see the next question. Find the sum of the measures of the interior angles of a convex octagon. Sum of the measures, so I know I'm going to be doing n minus 2 times 180 of a convex octagon. An octagon has 8 sides. Think of a stop sign. An octagon has 8 sides. 8 minus 2 is equal times 180 degrees is equal to my number of degrees. 6 times 180 degrees is equal to 1080 degrees. So if I add up all of the angles of an octagon, I will get 1180 degrees. Let's go on to the next example. Problem D says, find the measure of each interior angle, so make sure that you find all the actual measures, not just x, of a pentagon which has 5 sides as shown. So I know that a pentagon has n minus 2 times 180. That will be 5 minus 2, 180. Leaves me 3 times 180, which is a total sum of 540 degrees. So when I add up all of my angles, I should have 540 degrees. So let's start with h. 2x plus j, which is 142, plus k, which is 2x, plus l, 3x plus 14, plus m, 3x plus 14. All of that equals 540 degrees. Now we'll combine some like terms. I have 2x, 2x, 3x, and 3x. So that's 4 and 6 is 10x. 142 plus 14 plus another 14 is 170. And all of that is equal to 540 degrees. Now I can subtract 170 on both sides of my equation to keep it balanced. It's 540 minus 170. That leaves me with 10x is equal to 370 degrees. If I divide both sides by 10, I lose a 0 on each side, and I have x is equal to 37 degrees. Now I have to go back and look at my original problem. 2 times x, so 2 times 37 is going to be 74. I know that k is also going to be 74 degrees. This one, j, I know. It's 142. I also have 37 times 3 plus 14, which is 125 degrees. And 125 degrees. I have now answered the whole problem. I've answered the full question, which was to find the measure of each interior angle.